Hello dear students, hopefully you are fine. This is Professor Azmat Ali. I welcome you all in class of Operation Research. In today's lecture we will discuss an important topic that is known as the maximum flow problem. This topic is actually from the network models. The objective of the maximum flow problem is to maximize the flow in the given network model. We have given a network model and our target is to find the maximum flow from the starting node to the end node. That will I call later source and the sink nodes. The algorithm that can be used to find the maximum flow is known as the Ford Fulkerson Algorithm. So the Ford Fulkerson Algorithm is used to find the maximum flow in the given network model. Before going to start a numerical question, I will discuss here some important basic terms that are associated with this lecture. So firstly, I will discuss what is source and the sink. Actually, source and the sinks are these are the two types of the nodes. What is source? Source is a node which have only outward edges. As in the figure, you can see that node 1 is a source node because it has two edges. One edge is from node 1 to node 2 and other edge is from node 1 to node 3. At this edge, what is edge? Edge is actually a line that connects the two nodes. What is node? Node are actually the circles. In the figures, you can see that there are the 7 circles in the figures. So these are the actually 7 nodes that are connected by lines. These lines are actually called the edges or the arcs. Okay. So source node 1 is actually source node because it has only outward edge but no inward edge. It have only outgoing flow but no incoming flow. For example, from node 1 to node 2, there is an edge having 7 unit of flow, whereas node 1 to node 3 there is a 10 unit of flow. What is sink? Sink is a node which have only inward edge but no outward edge. In other words, it has only incoming flow but no outgoing flow. For example, in the figure, node 7 is a sink node because it has only 2 inward edges but no outward edge. One edge is from node 5 to node 7 and other is from node 6 to node 7. Next, what is the difference between flow and capacity? Flow is actually the amount of material. Your material may be your data, your water supply, your traffic flow. So the flow is the amount of material that can passes from an edge. For example, in the figure, from node 1 to node 7, the flow is of 7 units. From node 1 to node 10, there is a flow of 10 units. What is capacity? Capacity is actually the maximum amount of flow that can passes from an edge. For example, oftenly you see a bridge. Let's consider a bridge. You see number of vehicle at any time passing over the bridge. This number of vehicle shows the flow, whereas the natural question that arises here, how maximum number of vehicles can passes over the bridge. So the maximum number of vehicle that can pass over the bridge shows the capacity. So capacity is actually a type of flow, but this is the maximum amount of flow. What is the bottleneck capacity? Bottleneck capacity is actually associated with the path, and path can be formed by 2 or more than 2 edges. For example, in the figure, one of the path is this. From node 1 to node 2, from node 2 to node 5 and from node 5 to node 7. This path join source node and the sink node. So this is a way by which we can reach from node 1 to node 7, from source node to node sink node. Now this path has 3 different edges. One of the edges from node 1 to node 2, second is from node 2 to node 2 to node 5, and third is from node 5 to node 7. Each edge has a different capacity. For example, node 1 to node 2 has 7 unit of capacity or flow. Second capacity is from node 2 to node 5, that is 5 units. And third is from node 5 to node 7, that is 10 units. Now, what is the minimum among these 3 numbers? What is the minimum among these 3 numbers? This is 5. So this smallest number, this minimum number among these capacities shows the bottleneck capacity. So the bottleneck capacity of this path 1, 2, 5, 7 is 5 units. Let us consider another example. For example, if we take this path from node 1 to node 3, from node 3 to node 6, and from node 6 to node 7. This path also has 3 edges, and the capacity of each edge is, one is 10 unit, other is 7 units, and third is 4 unit. Now the minimum of these 3 number is 4. So I can say that the bottleneck capacity of this path is 4. So I hope you have clear about bottleneck capacity. The bottleneck capacity is actually associated with the path, and path can be formed by 2 or more edges. So the smallest number or the minimum capacity among these capacities of all edges shows the bottleneck capacity. Fourth one, what is the residual graph? Actually, residual graph is a transformed version of the original flow network used in network flow algorithm. Residual graph is actually is the update version of the given network flow model. I will discuss it later when I will solve a numerical question. What is augmenting path? An augmenting path is a path from source to the sink in the residual graph of a flow network where every edge in the path has a positive residual capacity. So augmenting path, actually this is a path of the residual graph, such that the residual capacity of every edge should be positive. What is the residual capacity? Residual capacity is actually the difference between the original capacity minus bottleneck capacity. For example, suppose our first path is 1 to 2, 2 to 5, 5 to 7. I want to find the residual capacity of this edge. As the bottleneck capacity of this path is 5 units, so the residual capacity of the edge from 1 to 2 is the difference between 7 minus 5. The capacity of the node from the capacity of the edge from node 1 to node 2 is 7 units, whereas the bottleneck capacity of this path is 5 units. So the difference, that is 7 minus 2, that will become 2. So 2 shows the residual capacity of this edge. Similarly, in this path, the residual capacity of this edge will be 0, because bottleneck capacity is 5. 5 minus 5, this will become 0. Similarly, the third edge, that has a capacity 10 units, whereas the bottleneck capacity of this path is 5 units. So the difference will become 5. So 5 shows the residual capacity of last edge. Now we will discuss here a numerical question. Next, let us consider a numerical example. Suppose I have this model, and our target is to find the maximal flow of this network model. Uh, what is the working rule? These steps will be helpful to solve a numerical question. Firstly, find an augmenting path. You can choose any path, any augmenting path. What is augmenting path? A path that joins source to the sink. Here the arrow's direction have also contribution. That, for example, from node 1 to node 2, the arrow is from node 1 to node 2. That have a 7 unit flow. But there is no reverse direction. That is, the reverse flow is not possible here. The flow from node 1 to node 2 is 7 unit only allowed, whereas from node 2 to node 1 there is no direction like this. This is not allowed. So the reverse flow is not allowed here. So firstly we consider an augmenting path. Suppose at the starting, this is iteration 1. Find an augmenting path. Suppose I choose augmenting path is, my augmenting path is node 1 to node 2, node 2 to node 5, node 5 to node 7. Second step is find the bottleneck capacity of this augmenting path. Bottleneck capacity. Bottleneck capacity of this augmenting path is actually the minimum of the capacities. At this edge you can see that there are the 3 capacities. One is from node 1 to node 2, that is 7 unit. Second is node 2 to node 5, that is 5 units. And third is from node 5 to node 7, that is 10 unit. So the minimum of these 3 number is 5. So the bottleneck capacity of this augmenting path is 5 unit. Third, subtract this bottleneck capacity from capacity of every edge of augmenting path to find residual capacity. Next we find the residual capacity of every edge of this path. So for this we again make this network model here. That is, we will update the given network flow. So again make So this is the original figure. Now we update this figure as all the capacities that are in the augmenting path will be changed. That will be the residual capacity. Here the capacity of the node 1 to 2 is 7 unit. So the residual capacity, which is the actually difference of the capacity minus bottleneck capacity, this is 7 minus 5, this is equal to 2. From node to node 5, the capacity is 5 unit. 5 minus bottleneck capacity, this will become 0. Node 5 to node 7, the capacity was 10. Now it become 10 minus 5, that is equal to 5. So the residual capacity of this edge will be 2 unit, 0 and 5, and the remaining figure will be remains same, that is here 1 unit, 10 unit, 2 unit of capacity, 2 unit of capacity, 3 unit, 3 unit, 2 unit, 4 unit, 7 unit. Further, as this is our sink node, so last step, add bottleneck capacity at sink after every iteration to find maximum flow. What is the bottleneck capacity of this iteration? This is 5 unit. So we add here at sink node this bottleneck capacity. So the flow after first iteration will be 5 unit. So bottleneck capacity, when we subtract bottleneck capacity from every edge of the augmenting path, we obtain residual capacity, whereas the same bottleneck capacity will be added to the sink node to find the optimal flow at every iteration. Further, as the residual capacity of the node 2 to 5 is 0, so this edge is blocked now and cannot be used in the further iteration. This is figure 1, and you can write it here as residual capacity of edge from node 2 to node 5 is 0. So this edge is blocked and node will be used in further iteration. Repeat this process until no more augmenting paths are found. Further, again we find an augmenting path. Next we consider another augmenting path. Augmenting path is one of the paths that can join node to the sink. So this is our iteration 2. Consider another augmenting path. Suppose at this time I choose here node 1 to node 3, node 3 to node 6 and node 6 to node 7. Augmenting path. Is node 1 to node 3, node 3 to node 6 and node 6 to node 7. Second step, find the bottleneck capacity of this path. Bottleneck capacity. This is the minimum of all capacities. First capacity is 10 units, 7, 4. 10, 7, 4. This will become 4. So we update figure number 1, that is called the actually resulting graph, residual graph, sorry. Update version of this figure is called the residual graph. That can be obtained by subtracting, as I have discussed in previous iteration, we subtract this bottleneck capacity from every capacity of this edges and add this bottleneck capacity at the sink node to find the optimal flow. So the figure number 2 will become, figure number 1 will become node 1, node 2, node 5, this is node 7, this is node 3, node 6 and this is node 4. Node 1 to node 2, now the capacity is 2 here. Node 2 to node 5, capacity is 0. Node 5 to node 7, this is capacity 5. Node 2 to node 3, this capacity is 1. Node 2 to node 4, this capacity is 3 unit. Further, this capacity is 3 unit. Node 3 to node 4, this capacity is 2. Node 2 to node 6, this is capacity 2. Node 5 to 6, this is capacity of 2 units. Now the remaining capacities will be changed. Actually, these capacity are associated with our augmenting path. So the residual capacity of this edge will be this will be 10 minus what is bottleneck capacity. This is 10 minus 4. This is equal to 6. Second is, here the capacity is 7 unit. Residual capacity is 4 unit. This will become 3. 6 to 7. Residual capacity will become bottleneck capacity minus original capacity minus bottleneck capacity. This is 0. This is figure 2. Again, as in figure 1, as the residual capacity of this residual graph or figure 2 from node 6 to node 7 is 0, so this edge, that is from node 6 to node 7, is blocked now and cannot be used for the further iteration. Next, again, whether there is an other augmenting path possible here? Yes. Or also, now the flow after second iteration will be, at first iteration flow was 5 unit, now the flow is 5 plus 4, 9 units after second iteration. Again, we find augmenting path for iteration 3. Now augmenting path we choose here, suppose we choose here 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 7. What is 1 to 2, so consider the augmenting path node 1 to node 2, node 2 to node 3, and from node 3 to node 4, node 4 to node 5, and node 5 to node 7. Now this path has bottleneck capacity. From node 1 to node 2, this has 2 unit capacity. From node to node 3, this has 1 unit capacity. Node 3 to node 4, this has 2 units. Node 4 to node 3, this has node 4 to 5, this has a 3 unit capacity. And from node 5 to node 7, this has a 5 unit capacity. What is the minimum? Minimum is 1. So the bottleneck capacity is now 1. Again, as similar previous, we update the figure number 2 or the resulting residual graph is, this is node 1, node 2, this is node 5, node 7, node 3, node 6, this is node 4, this will be changed, this is already 0, this will be changed now, this will be changed also, 4 to 5, this is also will be changed, 5 to 6, 6 to 7, this is already 0, 2 to 3, 3 to 6, 2 to 4, 4 to 6. Okay. Next, the residual capacity now. This is 2 unit minus, what is the bottleneck capacity? 1. This will become 1. From 2 to 3, 2 to 3, this is 1. 1 minus 1, this is 0. Okay. From 3 to 4, this is 2 unit. 2 minus 1, this is 1. 4 to 5, this is 3. 3 minus 1, this is 2. Lastly, node 5 to node 7, the capacity is 5. Bottleneck capacity is 1. This will become 4, that is residual capacity. And the flow after third iteration will be, this is 9 plus 1. 1 mean bottleneck capacity. This is 10 unit flow after third iteration. Whereas the remaining capacity will be remain same. This is 6, this is 3, and this is 2 unit. Okay. Now the node 2 to node 3, this edge has been blocked because the residual capacity becomes 0 here. Whether the augmenting path possible? This is figure 3. Whether the augmenting path possible here? Oh, yes, one augmenting path is possible here. Node 1 to node 3, that is 6 unit, that have a 6 unit capacity. Further, node 3 to node 4, this has a 1 unit capacity. Then from node 4 to 5, this has a 2 unit capacity. And from node 5 to node 7, this has a 4 unit capacity. We will not move from node 5 to node 6, because if we move from node 5 to node 6, this has a 2 unit capacity, but the next direction is from node 6 to node 7, but this edge has been blocked here because this capacity is 0. So we will not move from node 5 to node 6. So the next augmenting path is, now augmenting path is now the augmenting path is node 1 to node 3, node 3 to node 4, node 4 to node 5, and lastly from node 5 to node 7. Yes. Okay. What is the bottleneck capacity of this augmenting path is? This is the minimum of node 1 to node 3 has a 6 unit capacity. This is 6. Node 3 to node 4 has a 1 unit capacity. And further, node 4 to node 5, this has 2 unit capacity, and lastly from node 5 to node 7 has a 4 unit of capacity. Sorry, I forgot to write the capacity at this edge. This was 3 units in the last iteration 2. Our fourth iteration is continue. The bottleneck capacity now is 1. So consider the edges that are the part of our augmenting path. One is 1 to 3. This is capacity 6 unit. 6 minus 1, this is 5. This is the residual capacity. Second is 3 to 4. 3 to 4, the capacity is 1 unit. Now 1 minus 1, this will become 0. Further is 4 to 5, this is 2 unit. 2 minus 1, this will become 1. And lastly 5 to 7, this is 4. 4 minus 1, this is 3. And the remaining capacities on all other edges will be remain same. This is 1, 0. This is 0. This is 3 unit. This is 2 unit. This is 3 unit. This is 0 unit. Again here the capacity is missing. Again sorry, this is 2 unit capacity here in second iteration. So this is also 2 here. Now the flow after fourth iteration will be 10 plus bottleneck capacity, this is 1, that is 11 unit. Now there will be last iteration, there is a last augmenting path possible here, or that is from node 1 to node 2, node 2 to node 3, node 2 to node 4 that have a non-zero capacity 3 unit here, and node 4 to node 5 this is 1 unit non-zero capacity, and 5 to 7 this has 3 non-zero capacity. So consider the augmenting path from node 1 to node 2, node 2 to node 4, and from node 4 to node 5, and node 4 to 5, or 5 to 7. Okay. Now the bottleneck capacity from node 1 to node 5 at this time, this is 1. From node to node 3, this has 3 unit. Node 4 to 5, this has 1 unit capacity, and 5 to 7 this has a 3 unit capacity. So the bottleneck capacity at this time, this is 1. Resulting residual graph is. Now consider the edges that are the parts of our resulting path. One is 1 to 2, node 1 to node 2, this will become here the capacity is 1 unit, residual capacity will become 1 minus bottleneck capacity, this is 0. Okay. Further part is node 2 to node 4, node 2 to node 4. Node 2 to node 4 has a capacity 3 unit here, so the residual capacity will become 3 minus 1, this is 2 unit. Okay. Node 4 to node 5, node 4 to node 5 this has a 1 unit capacity, this is 1 minus 1, that will become 0. Lastly from node 5 to node 7, this is 3 units, 3 minus 1, this is 2 units, and the remaining capacities remain same, that is 5 here, this is 5, this is 3, okay, 0, okay, this is 2, this is 0, this is 0, okay, and the final flow is now 11 plus 1, that this is equal to 12 after fifth iteration. Further there is no augmenting path is possible, so the last residual graph or last pattern shows the maximum flow, that is the optimal flow, which is 12 unit here. So I hope this video will be helpful for you. Inshallah, we will discuss a new topic in the next video. Take care. Allah Hafiz.